Welcome to JDesigner Tutorial 3, Modeling a Simple Cycle. In this tutorial, you will investigate the basic properties of a simple cycle and introduce the idea of parameter scans. Such cycles are very common in signaling networks, and thus an understanding of their properties is very important. We will start by entering a model into JDesigner. We will lay two nodes on the canvas and connect them each with uni-uni reactions. In biological terms, the forward arm V1 might be catalyzed by a kinase, and the reverse arm V2 a phosphatase. We are going to investigate the effect of varying the activity of V1 on the steady-state concentration of node 1 and see how this response is affected by the values of the enzyme KMs. Change the reaction type for reaction 1 to irreversible Michaelis-Menten and change Km to 5. For reaction 2, change the reaction type to irreversible Michaelis-Menten and change Vmax to 1 and Km to 5. Open the Species Properties panel and change the concentrations of node 0 and node 1 to 3 units each. We are now going to use the parameter scan feature to investigate how the activity of the first Vmax affects the steady-state concentration of node 1. To make sure that you have entered everything correctly, compute the steady state with the current values. You should get the following steady state values for node 0 and node 1. You should see the values that appear on the screen now. Once you can reproduce the values on the screen, we can begin to scan the parameter range. To do this, select the Scan Parameter tab on the Steady State Control panel. The first thing to do is select the particular parameter we wish to scan. In this case, it will be the first Vmax, J0 Vmax. Next, we must set the min, max, and density parameters. Set these to 0.1, 4, and 80 respectively. These indicate where to start the scan, when to finish, and how many values to compute. Now open the graph panel, and then run the simulation. You should get the graph that appears on the screen. This graph shows a simple hyperbolic response as the Vmax is increased, nothing particularly interesting. We will now see the effect of changing the two reaction Kms on this response. Change both reaction Kms from 5 to 2. Run the simulation at these new values, and you should get the graph that appears on screen. As you can see, the response has changed from a simple hyperbolic to a sigmoid response. Change the max value from 4 to 2 in order to rescale the graph, and then decrease the Kms further to 0.25. Then, run the simulation again. Assuming your graph looks like the one shown on the screen, decrease your Kms further to 0.05. And then run the simulation again. As the Kms fall, the sigmoid character becomes more and more pronounced. In fact, it becomes almost switch-like. This property is well known and is called ultrasensitivity. The property enables the network to convert a graded input into an on-off response. This concludes Tutorial 3. In Tutorial 4, we will introduce a bistable model and illustrate its unique switching properties, as well as introducing the notion of free format rate loss.